In this session, we're going to look at products of complex numbers in polar form. Given two complex numbers in polar form, we can define the product if z is equal to the modulus of z times cosine of alpha plus I times the sine of alpha. And if we let w equal the modulus of w times cosine of beta plus I times the sine of beta, then we can define the product z times w as the modulus of z times the modulus of w times quantity cosine of alpha plus beta plus I times the sine of alpha plus beta. That means that when we multiply two complex numbers together, we multiply the moduli and add the arguments. For example, we let z equal 8 times the cosine of pi over 4 plus I times the sine of pi over 4, and let w equal 6 times the cosine of pi thirds and I times the sine of pi thirds. Then the product z times w will be 8 times 6 times quantity cosine of pi over 4 plus pi thirds plus I times the sine of pi over 4 plus pi thirds and quantity. Product of complex numbers is forming scaled rotations of things. So 8 times 6 gives us 48, and we have the cosine and pi over 4 plus pi over 3, finding a common denominator would give you 7 pi over 12, and I times the sine of 7 pi over 12. Now suppose we wanted to multiply two numbers that were not in polar form. So if we had z is equal to 2 square root of 3 minus 2i, and w is equal to negative 1 minus the square root of 3i, how would we go about finding the product? Well, we could convert each to polar form and then see how the angles add together, moduli multiplied. Or we simply multiply it out and then write our answer in complex form as well. Let's take the first route. The modulus of z is the square root of 2 root 3 squared plus a negative 2 squared. And the modulus of w is equal to the square root of negative 1 squared plus negative square root of 3 squared. And when we simplify each of those, the modulus of z would be 2 root 3 times 2 root 3 is 12, and 2 squared gives us 4. Square root of 12 plus 4. And that gives us the square root of 16, which simplifies as 4. And the modulus of w is negative 1 squared is 1, and square root of 3 squared is 3. Modulus of w is the square root of 4, which is 2. Now, if we have angle alpha is in the argument of z, then we have the tangent of alpha is equal to the imaginary part of z over the real part of z. And that gives us the tangent of alpha as negative 2 over 2 root 3, and that gives tangent of alpha as negative 1 over the square root of 3, and that angle is in the fourth quadrant. Our complex number would be in the fourth quadrant. So alpha is negative pi over 6. And likewise, the tangent of beta is negative square root of 3 over negative 1, and tangent of beta is the square root of 3, and our angle is going to be in the third quadrant. The number negative 1 minus square root of 3i is in the third quadrant. Tangent of beta equal root 3 in the third quadrant would produce 4 pi over 3. as our angle. Therefore, z times w is 4 times 2 times the quantity, the cosine of negative pi over 6 plus 4 pi over 3 plus I times the sine of negative pi over 6 plus 4 pi thirds. And when you find a common denominator between negative pi over 6 and 4 pi thirds, you can get 7 pi over 6. So let's put it up here and say the product z times w, 4 times 2 is 8 times quantity, cosine of 7 pi over 6 plus I times the sine of 7 pi over 6. And that's the product of the two complex numbers in polar form. And if you rewrite in standard form, you would see that z times w is negative 4 root 3 minus 4i. If you were to multiply in standard form, you would end up with that.